given data is true length is 100 mm. Plan is given 80 mm. Elevation is given as 70 mm. Location of P is given as 10 mm above HP and 15 mm in front VP. We need to draw projections and we need to find theta, that is angle with HP, and phi, angle with VP. We need to find out this. So we will now see how we can proceed further. In the projections of line, first of all we always draw a horizontal XY line. First of all we will draw a horizontal XY line. XY line. Now we will locate the point P. We will locate the point P. It is been given that it is 10 mm above HP, which means that 10 mm above XY line and 15 mm in front of VP, which means that 15 mm below XY line. HP component will be denoted by dash, VP component will be denoted by regular alphabet only. Now we have been given that we have plan and elevation length also. First of all we will draw parallel lines from this P and P dash to the XY line. We will draw parallel line to the XY line. First of all, now we have been given that we have plan of 80 mm. So we are marking it 80 mm, naming it Q1. We will take perpendicular projections from it. Draw an vertical line. Now we have been given that we are having true length of 100 mm, which means that our PQ line is of 100 mm long. So what we are going to do, we are going to locate this PQ line of 100 mm. Take P dash as center and mark an arc on this vertical line. We have got the Q dash. Join this line. This is our true length. TL is equal to 100. This is our true length. Again draw parallel line to XY line from this Q dash point. parallel line to the xy line from the q dash point. Now we have been given that elevation length is of 70 mm, which means that we have got this elevation length of 70 mm, marking it as q1 dash, taking q1 dash as p dash as center, q1 dash as radius, marking an arc. Joining this p dash to capital Q dash, we have got our elevation. If you want to measure that, elevation is given 70 mm. Over here we are getting it 70 mm as well. Now we have been given the plan of 80 mm, and this again this we need to find out this theta and phi. So we have got this theta, we will measure it. Theta is coming as 34 degree. So theta is coming as 34 degree. In this answer we will write down 34 degrees is our answer. Now we need to find out the phi. So how we are going to find out? Elevation and plan are always in the same thing. So we are going to take the projections from the elevation to the lower level. Now we have got the plan length of 80 mm. Plan length of 80 mm. We will take radius of it PQ1 as radius, P as center, and we have got this capital Q, which is our plan. Again, drawing a parallel line to the XY line from this Q. Again, drawing a parallel line from Q to the XY line. Now we have got true length for the plan. So what is our true length? True length has been given as 100 mm, which means that we need to take radius as P dash Q dash as radius, P as center, mark an arc on this parallel line, and you will get your desired true length. Join this P to small q. Again, this is our true length of 100 mm. This is our plan. Theta we have already find it as 34 degree. We need to find out this phi. Phi, we'll measure it and write it in the answer. The phi coming as 43 degrees. Phi is equal to 43 degrees. So we will write it into the answer that we have got this phi as 43 degrees. Again, we will repeat the procedure. First of all, we will write the given data so that we don't miss out any sort of important data as well. In the projection of line, first of all we will draw XY line and take the location of P and P dash. Then we have been given the elevation and plan length. So accordingly, from P dash we have taken the radius and we have got the elevation. We have been given the true length. I have cut it arc as true length. Elevation and plan are always in the parallel thing, so we have got the plan as well. Taken parallel line to the XY from it, mark out the arc and get it true length. Measure the angle with HP and VP and we have write it into answer. So that is the end of our part 2 of GTU paper solution engineering drawing December 2013. Thank you very much. See you soon.